Now, here's what does this word mean? Remind me what mutually exclusive means. What does mutually exclusive mean?
No shared members.
Good, no shared things. So what that means is if it's mutually exclusive, that means those two things can't happen at the same time. So I said last time on your OR formula, on your sheet sometimes and in the book, it looks like there's two different formulas for OR, but really there's what? There's one. It's just, if they're mutually exclusive, that and part's going to be a 0. But subtraction 0 is not going to freak anybody out. Now, the other thing that's important on that and formula is this. And here's what I'm going to do. I'm going to write down an and formula after I talk about two words. Independent events versus dependent events. All right, independent events versus dependent events. Now, if I'm independent, does what you do really affect me? Not really. That's what independent events mean. It means the probability of one event is not affected by the second event. So the probability of one event is not affected by the probability of the other event. Now, what do I mean by that? If I take a coin, like we did that very first day, and somebody starts flipping it, if they flip it the first time and they get heads, does that affect what they might or might not get on their second flip? Just because you got heads the first time doesn't mean you're more likely or less likely to get heads what? The second time. Those two events are independent. Okay? If I pick a card from the deck and I got the ace of spades and I write down the ace of spades and I put the card back in the deck and shuffle them up, does me getting the ace of spades the first time in any way affect what I might get the second time? No. Then they are what's called what? Independent. All right. Now, if something is dependent, does one affect the other? It what? It does. All right. So in your books, I'm gonna write that definition down in a second. I'm trying to see where they stick it in your book so that in case you'd like to look at that, they're on page 151. Okay. So basically, that's what it means. The probability of one event is affected by the other event. So when one does affect the other, then that's dependent. When one does not affect the other, that's what? Independent. So let me ask, let's go back to picking the card. If I pick the card the first time and I get ace of spades and I write it down, what if I keep the ace of spades? I don't put it on. Does that change the probability of something I might get the next time? Why? What's one thing that's already changed? The total's different, right? So before I had 52 cards, now I've only got what? 51 cards. So my chance of everything changes. Here's the other thing. Am I going to get the ace of spades the second time? No, that ain't happening. You see what I'm saying? So when you don't replace things, it gets sticky. You move from independent a lot of times to what? To dependent. So what's going to happen is this. Again, I'm going to kind of fudge a little bit. Your book acts like there's two different formulas for and. All right? I'm going to let you write it one way as long as you understand what you're writing. All right? Let me show you what I'm talking about. The probability of A and B. Now I'm going to keep emphasizing this, or I'm going to nail you on a pop test with a big test. When you see and, what's the first thing you should ask yourself before you do anything? Look back in your notes from last time. Hopefully you wrote it down. But if you didn't, it's going to cost you points at some juncture. What am I going to ask myself first? Is it possible? Okay? Because like Delaney said, okay, well, what if it's not possible? Do I grab the formula? If it's not possible, what do I write down? Do I write down not possible? No, probability is not a phrase. Probability is a number. So if it's not possible, what am I going to write down? I'm writing down 0. Don't grab the formula. Because that formula is only meant to be grabbed if you're doing more than one thing. So you'll get a pretty answer, but it won't be right. So before you grab that and formula, ask yourself, is this possible? If the answer is no, write down 0 and go on. If the answer is yes, then go to the formula. Now, there are two formulas on your formula sheet. This one is exactly correct, and I'm going to explain it. And then it's got this one. And it says use this one if they're independent, use that one if they're dependent. All right. Now, here's what I'm going to do, just to make life a little bit simpler. I'm going to use this one, but I'm probably going to write it this way, as long as I really remember in my head that when I look at this, I see this. Here's what this means. This one means what's the probability that B occurs given that A has occurred. In other words, I've got to remember that I'm assuming when I do the second thing that the first thing has already what? Because if they're dependent, it matters whether I'm putting the card back or I'm what? Not putting the card back. Because the probability of the second thing is going to be different. Now, this one just says you don't have to worry about the first thing because the two events are independent. But what I'm going to write on the board, I'm going to write this second one down all the time, but really in my head, do you understand I am always looking at it like this? I'm assuming this first thing has happened when I go to do what? That second thing. Now, we're going to work some problems just to kind of make sure we're clear about that. All right? Now, let's get away from cards for a second. What if I told you that I had a bag of marbles? And in my bag of marbles, I've got 3 red ones, and I've got 6 blue ones, and I've got 1 green one. All right, so let's kind of back up and review and then kind of move on. Just do me this one. Here's question 1. I want you to find me the probability that it is blue, and I'm letting you pick 1 marble. So you're picking 1 marble. All right, find me the probability that it's blue. As you see, when somebody goes in or out, it dings. Just really helpful for me. Because if you're not there the whole time, there's no credit for coming. Now, if it's just one thing one time, so what always goes on the bottom when I do a probability? Right, what's my total? 10, okay? So totals go on the bottom. What's in the parentheses goes on top. So how many are blue? Now again, you can't leave it like this because it's not reduced. You can either change it to a decimal or you can reduce it to a fraction. I don't care. Everybody with me? So I'd take 3/5 or I would take 6/10. Elizabeth?
When we reduce to a decimal, how many places do you want?
3 or 4.
Okay.
3 or 4, as long as, now if it terminates before that, you're good, of course. But don't round to 0 and don't round to 1. So if I've got to go 14 places, so it doesn't round to 0, I'm going to have to go 14 places, but 3 or 4 places. Okay, good question. All right, do this one. Anybody good about that one? Okay, try this one. What's the probability that you pick a red or a green? Right. So you pick one marble, what's the chance it's a red or a green? All right, so we understand that's a probability of red. What do you do with the or? Add, so plus the probability of a green minus the probability of red and green at the same time. Okay? So what's the chance that that marble was red? Out of your 10 marbles, how many were red? 3. All right, what's the probability that it's green? How many out of your 10? 1. Minus, what's the chance it's red and green at the same time? You have any striped marbles? So what's that one going to be? 0. So again, I'm going to get 4/10, and again, you can't leave it that way. You can either change it to the decimal, or you can round it to, you can reduce it to 2/5. Your choice. All right, so try this one for me. Okay. That's number 2, here's number 3. Do this probability. And Jane, what's my answer? Remember, what's my answer? 0. There's no work. You do not grab that formula. Everybody understand why? That formula assumes I'm doing what? More than what? One thing. See, remember what I told you, before you grab that and formula, you got to ask yourself, is it possible? If you're picking one marble, can it be red and blue at the same time? No. So what's your answer? 0. Don't write down. You can write down not possible if that's not going to get you any credit. Because when something's not possible, you're supposed to know the probability is what? 0. Now, if I said this, What's the probability that it's red and blue? What if I let you pick 2 marbles? Now is it possible? Yes. Now, but you still need to know something. What do you need to know that I haven't told you yet?
Replacement.
Okay, so what if I say with replacement? Okay, what's the probability that you get a red one and a blue one, you pick 2 marbles with replacement? So that means you get a red one the first time and a blue one the second time. There's an order that's implied there in that form.
So would we also consider blue and then red too?
No, that formula is A first and B second. That's a very good question. And we'll talk about later what would happen if you did do that. All right, what do I do with and? Do I add them? What do I do? Multiply. But again, if you want partial credit, I've got to do the probability of red times the probability of what?
Blue.
Now, really, we understand I'm doing blue given that I got red the first time. Is everybody with me? So I'm doing that in my head. I'm making that assumption. So when I go in for my first pick, how many marbles are there? 10. Of those, how many are red? 3. Now, what are you assuming is in your hand right now? How many marbles? 1. What color is it? Red. What are you doing with this 1 red marble? I'm putting it back. So when I go back in, what's my total? Still what? 10. How many are blue?
6.
Everybody okay? Now again, I've got to multiply. So 3 times 6 is 18. Is it 18 tenths? It's 10 times 10, which is what? 100. Or 9/50. Now, like we were doing before, like the one that Kylie asked about, sometimes the connector word is going to be implied. What if I said this? What's the probability that you get 3 blue marbles and I'm letting you pick 3 marbles without replacement? So you're picking 3 marbles and they all are blue. Now, is picking 3 marbles one thing one time? I'm doing 3 things. Everybody with me? So there's got to be a connector word. So what's my implied connector word? What's the only way they're all going to be blue? The first one's going to be what? Blue. What? And the second one's going to be what? Blue. What's my connector word? And the third one's going to be what? Blue. They're not going to say, what's the probability that you get blue and blue and blue? Everybody okay? Now, what do you ask yourself? Is it possible? Now, is it possible that the first one's blue and the second one's blue and the third one's blue? Is that possible? Then I go grab the formula. So what's the formula say I do? It's the probability of just the first one. What's I do with and? Times the probability of just the second one. There's another and, so times the probability of the next one. Is everybody with me? Now look how many words I've got on this board. I don't have any numbers yet. All right. When I go in to pick the marble, what's the chance it's blue? How many are blue? 6. So 6, and my total was 10. Now, what do I assume is, how many marbles are in my hand right now? 1. What color is it? Blue. What am I doing with it? Keeping it. It's gone. So when I go back here for my second pick, what's my total? 9. Everybody see why it's 9? How many of those 9 are blue? 5. Because the marble that you threw away was what? Now again, how many marbles in your hand now? Another how many? Just what? 1. What color is it? Blue. What are you doing with this one? Giving it 2. So when I go back in, how many marbles are there? 8. Of those, how many are blue? So let's see what we've got. So we've got 6 times 5 times 4. So that better give me 120. And then I've got 10 times 9 times 8, which better give me 720. And then I'm probably just going to go to a decimal because it's quicker. Did you get about 0.166? Is it going to be 6 or 7? What's it going to be? 7. You put a 6, I'm going to count it wrong. We're not chopping off. We never chop off, we round off. So all that's really nothing new. That's just a review of order, review of what? And. All right, now let me show you another thing we need to look at. I want to go back to this formula at the top. Because sometimes there'll be problems that are written like this. All right. You pick one card. What is the probability that the card is a heart given that the card is red? Okay, you pick one card. What's the probability that the card is a heart given that the card is red? Now, we've gone over 2 connector words. One of them was or. What was the other connector word we just went over? And. Now we got a third one. Given. Now, look up here at this formula that I put on the board. I said this was what's the probability that B occurs? What's that phrase? Given that A has occurred. So what I'm going to need to do, there are going to be 2 ways to work this problem. I'm going to do it with this formula, and then I'm going to do it with common sense. You can do it either way you want to. Do you see, if I've got this formula, what if I want to solve it for this? What if I want to get rid of this probability of A? How am I going to get rid of probability of A on this side? What do I have to do algebraically to get rid of the P of A on this side? How do you undo multiplication? Divide. So if I divided this side by the probability of A, I'm going to have to divide that side by what? The probability of A. So what's going to have your probability of A's over here? They're going to do what? Aren't they going to go out? So does everybody understand that what I'd be left with is this? Now I'm going to write it with this on the left and that on the right over here. Okay. The probability of B, given that A has happened, is the probability of A and B divided by the probability of just what? A. So that's the same formula I had, just rearranged. But notice the order. Do you see that what's to the right of that bar is on the bottom? Because that's going to be real important in a second. So look at what it's asking me to do. It wants the probability that the card is a what? Heart, given that the card is red. Remember, that bar is given that. So that's the way I would write it. What's the probability that the card is a heart, given that the card is red? Now, what do you know for sure? Do you know that the card's a heart, or are you guaranteed the card is red? Which one do you know for sure? Given that it's what? So you're guaranteed the card is red. Now, if I work it with the formula, look what it says. On the top, I've got the probability of A and what? B. So this second thing and this first thing. So probability that it's red and a heart over the probability of red or heart. Which one is the one to the right of the bar, isn't it? So which one's to the right of the bar? Red. In other words, on the bottom is what you're guaranteed is true. Now, this is kind of like when you're doing odds. This is a probability on top of another what? Probability. So I'm going to get a fraction on top of another fraction. Let's do the bottom one first. If you pick a card, what's the chance the card is red? What goes on the bottom? Isn't it the total? What's my total? My cards were what? How many cards are there? 52. Of those cards, how many are this parenthesis? How many are red? 26. Aren't half of them red and half of them black? So you got your calculator, you can divide it and see. So does everybody see why the probability of red is 26 out of 52? We good? All right. On the top, the total is still 52. Now I need to know the chance that this card is red and a heart. How many cards in the deck are red and a heart at the same time? 13. Now, just like with odds, what if these bottom numbers match? What's going to happen to them? Isn't that 13 over 52 divided by 26 over 52? So isn't that 13 over 52 times, what do you do with the second one? Don't you take the reciprocal? 52 over 26. What's going to happen to those 52s? Aren't they going to divide out? So what am I going to be left with? 13 over 26. So do you see that when these bottom numbers match, they're going to go out? So I'm going to be left with 13 over what? 52. So that's 0.5 or a half. Now, that's using the formula. I probably wouldn't use the formula. I would use good old-fashioned common sense. So I would probably work it this way. What's the probability that it's a heart given that it's red? So remind me again, do I know for sure that it's a heart or do I know for sure that it's red? That it's red. Now, if you know for sure that the card is red, are there 52 possibilities anymore? No. If you know for sure the card's red, your total just got whittled down. How many? 26. Of those 26 cards, how many are hearts? I'm finished. See, what if I said, what's the probability that you have a king given that the card is black? Now, I'm going to do it with just good old-fashioned common sense. You are welcome to go do it with this formula. Do you know for sure that the card is black or that it's a king? That it's black. Well, then your total, this becomes your new total. If you know for sure the card's black, there are not 52 possibilities. There are only how many? 26. But now if you're going to do it this way, these have to come out of those. Of those 26 black cards, how many are kings? 2. King of spades and the king of clubs. Now I know there are 4 kings in the deck. So why don't I say 4? Because if I'm gonna use common sense, these have to come out of what? Those. In other words, this whittles your total down, and you're coming out of that total. So out of those 26 black cards, how many of those are kings? All right, so I would get 113. So when you're doing given that, you can either use this formula, or you can use kind of the shortcut, whichever one makes more sense to you. Just remember that on the top is both at the same time, and on the bottom is what's behind, what's to the right of that bar. And you're going to have a probability on top of another probability. You have to simplify it. So you get the same answer either way. Now, where's your homework going to be? On Moodle, but don't forget to do that video. I'll do it tonight, so in case something, this afternoon, in case Wi-Fi freaks out.